This section is on 2.1, rates of change. So let's go ahead and talk about some definitions for the rates of change. It says a moving body's average speed during an interval of time is found by dividing the distance covered by the elapsed time. So what we're actually looking for is the average speed formula. So it says right here the interval of time. Interval of time means we have two t's involved, right? Because we have intervals that we need to go to. And we also have this dividing, so that's a fraction. And we also have is the distance covered by the elapsed time, so that means we probably have two distance involved. So what does that look like in formula-wise? We have this delta y over delta x. So the delta y represents the distance, right? We said the distance covered by the elapsed time. So this is the distance, the two y's. And then we also have is the delta x represent the t's, the time interval that we have right here. Okay? Now, this is very familiar to us, right? We've seen this both in Algebra 1, also in Algebra 2, and pre-calculus as well. And what do we call this equation? Right, the slope formula. So that's what we're using is a slope formula. So let's try example number 1. So example number 1 is asking us, again, to find the speed, average speed on this. So we're using that formula that was just given for the time of t equals 0 and t equals 2 for the units of feet over second. Okay? The equation that we have is y equals 16t squared. Now let's think about this. 16t squared should be a shape of a parabola. So that's going to be this parabola right here. So this part right here is chopped off a little bit, but don't worry about that because that's not what we're concerned. We're actually concerned about this part of the parabola because at time t equals 0, which is this part right here at the origin, right, that's what we're going to use, and at time t equals 2, so this is about 2.5, so 2 is probably around here. We're finding the average distance, right, or average speed between it. So from here to here is what we're looking for. So what you actually look for is the slope between those two right there. That's what we're looking for, okay? So using the formula that was given, that delta y over delta x, let's go ahead and substitute. Now I actually substituted 16t squared because that's the y that representing as far as our equation right here, okay? So I have a 16t squared here minus 16t squared. It's the same equation, but don't worry, we're going to substitute our t's in here to substitute into this right here, so that's going to change right there, all right? I still have this t2 minus t1. Now let's go ahead and designate this as my t1, and this is my t2, so that way when I substitute it, it makes sense. So if I do that, this is t2, then notice that this right here and this number right here, the numerator and denominator should be exactly the same, okay? Same thing with here. Zeros, that's this part right here, is exactly the same, all right? So zeros will cancel out, beautiful. 2 squared is 4, 4 times 16 is 64, right? 64 over 2, right there. And then we simplify one more time. 64 over 2 is 32. And in this case, it's feet per second, the units right there, because again, we mentioned up here, the units was given, okay? Now, example number 2, we're going to do exactly the same thing, but we're going to change is the t equation instead. So I did not change this part right here because I just wanted you guys to practice as the algebra using t equals 2 and then t equals 2 plus h, which is a variable, all right? So using the same delta y over delta x, let's go ahead and substitute it in. I still keep my 16t squared, 16 minus t squared, right? Designate this as my t1, designate this as t2. So it's going to be a straight substitution on the numerator and denominator right there, right? No surprise. And the straight substitution right there with my 2's right there from here, okay? So now this begins as the algebra. So if you don't do the algebra correctly, obviously you're going to get the wrong answer. So pay attention to the algebra. So we have this a square right here, which means that you have 2 parentheses. So let's break those parentheses apart. And then from here, oh, my 4 right here is coming up from here. 2 squared is 4. So that's where I got this 4 right here. All right? So now from here, the 2 parentheses, let's go ahead and distribute it or FOIL it out. And that's going to give us this part right here. Notice I also get 64 right here because it's 16 times 4. I'm trying to simplify as much as possible and try to get rid of parentheses. Okay? So that's where 64 comes about. So my next algebra step is to take the 16 and distribute it inside the parentheses. So let's do that. So 64 plus 64h plus 16h squared minus 64 all over h. So right away you can see probably the 64's, right, will cancel each other out right there. So you're left with then is 64h plus 16h squared all over h. Now, if you stop right here, you're going to be wrong because in algebra, we always want to simplify as much as possible. So with this, we need to actually continue on because can you see? On the numerator, we probably could factor out an h from both this right here and also right here. All right? So let's factor it out. So if I factor out h right here, I'm going to have a 64 right here plus 16h all over h. And then from here, the h's will cancel out, right? And then you're left with the 64 plus 16h, which again, some of you will freak out because you have a variable at the end. But don't worry, because remember, you started off with a variable up here. So if you have a variable and you substitute it in, most likely you're going to have a variable at the end, all right? Whereas example 1, we only had 2 numbers, so that's why your final answer had a number. So let's go ahead and do the practice for this, okay?